Okay. Morning, guys. Assalamualaikum. um, I today I want to share with you what I did earlier. So I am working in another AI use case. So a typical use case for this is for data entry, or if you want to do a document digitization. Wow, that's one hard word. Right. So basically, the idea is to turn any paper document, document in paper hard copy, into more structured data. So the point for that is basically for that we can store or automate this process of digitalization into database. Right. So this could be, your company or yourself have plenty of, paper documents coming into your office, like invoices to be processed, or any kind of like a standard, templated document lah. Uh, you're working on receipts, or you're working on quotations that you want to process, and it's easier to process the these documents when it is actually stored as a structured data in database, so that you can play around with it. So the idea I'm taking today is basically for to follow this kind of pipeline, processing pipeline. So from a paper document, you turn it into an image, and then you load that image into an application pipeline, right? And then you optimize. So the first thing is to optimize the scan image, so that it's easier for the computer to do to do reading on it. So be it OCR or LLM, whatever it is. Right. So and then for a redundancy purpose, to get the maximal output, I also thinking to do a run or OCR for on this optimized image, so that we have some sort of text also for us to feed it to the LLM. LLM will be the main engine to read the optimized image and extract information from it. But we can also use the result from the OCR as a secondary data input lah, basically to say context. Right. So from that, the LLM will then extract the information we want and then turn it into a structured format, so that this structured format will become the input for the SQL query, or for the operation that we can store in the database. Right. So for today, I'm going to use, oh, sorry, I forgot. So today I'm going to use cursor IDE for the uh, for the for the idea, for the development process. And then I'm going to use Ada for the coding assistant. I'm going to use Cloud 3.5 Sonnet for the LLM model. This is basically right now is my favorite, but they did mention that Google, the latest Google, which is Google Gemini 2.0 experimental, is also really good now. But the last video I watched on one of my favorite YouTuber, uh, when he did a comparison, Claude 3.5 Sonnet is still a little bit better. So it doesn't matter. So as long as there's no big difference, I'm still going to use Claude 3.5 Sonnet, because uh, for the actually for the whole year that I've been using, uh, you know, not wholly, but half a year that I'm using the Claude 3.5 Sonnet, it has been very reliable for me. Right. So I'm going to this we're also going to use OpenAI Vision for the LLM engine, LLM Vision extraction model. Right. So for the development workflow, that means, how do I come up with the how before we build, we need to prepare. What are we going to need to prepare is basically the documentation of what are the breakdown of steps, so that we can do this in one go when we have the plan for it. So for the development flow, these are my typical workflow. So whatever the idea that I have for me to build, I'm going to prompt it to AI to first produce the base requirement. So what is this base requirement is the general breakdown steps for me to achieve my final output, right? So for example, let's say one example. So what if you want to convert paper-based document into an OCR output, for example. So the general step should be, turn it to image, and that one should not be part of this lah. Let's just assume, for simplicity reason, let's assume we already have the scan image. So from the digital image, what we're going to do is we have to load it to the application. And when we load it in the application, then we need to do the image enhancement to the auto. contrast and brightness, whatnot, so that we, the image is no longer have any shadow or whatever else. Then you can only see the text of the document, and then from that you pass it on to the OCR processing. So basically, that's the general breakdown of the step. So when you have that general breakdown of steps, then you work on the individual steps. So you drill down each step and create a detailed plan. But this is not the code itself, but it's just the detailed plan. How are you going to code this? But it's in the pseudocode format, so that this we can also document. And then from this document, the in pseudocode, then again you pass it to the AI and say, okay, this is my pseudocode. Now generate and implement the full code, right? So that's the step basically. So then you go on to the next step and the next step, and then each one for the each full code that you have generated by the AI, then you test and then you iterate prompting, and if there's any issue until you get your expected result. So that's basically the development workflow that I'm using, right? So while using Ada, note that there's two mode that you can use Ada. One is the architect mode and one is the code mode. Architect mode is when you use the /architect command, and you use this when you are doing strategy and planning and breaking down steps in non-coding kind of tasks or work, right? Because architect mode has better algorithm to think step by step to break down operation and processes. While the code mode is very specific when you want the AI to generate the code, right? So those two mode, if you use this properly, then you can get the best out of Ada, right? So enough with that. So let's look at the code. Okay, so this is what I have right now uh, so far. So if you notice, there's a requirement folder here where I have the base requirement generated. And then based on the base requirement, I already have drilled down on the detailed steps in pseudocode on tackling the step-by-step process, which is the first will be the image input planning, and then the image enhancement planning, and then the OCR processing. I also added here the database, how to store into database planning. Uh, but this is pretty typical if you want to do any data insertion or data storage into database, then you still need this process, right? So uh, how do I get this? So let's look at the history of the chat, right? So this is the starting point. So I started off by asking uh, AI to create detailed planning. Oh, sorry, this is actually a detailed planning. Let's look at the more general one that I start off to generate the basic. Okay, so my prompt, create a base requirement in the requirement folder, right, to document the app that we are building today. Right. So what I want to build is a simple command line interface app that can first get an image from a folder, the image that we want to work on, and then of course we're going to look into the application. That would be the same step. And then we're going to run auto brightness contrast algorithm to make the text in the image very readable or legible. Then the next step will be running the OCR on the process image from step 2. Basically, I have over time, I also you know uh, I realized that I still need the two more steps. Step 4 will be the running the uh, process image through the LLM, which is a better OCR per se, to extract information from the image, and then of course to store the structured output from the LLM to the database, right? So I have added those information a bit later in the project, but at first this is my base requirement. So you can see that AI actually produce the this basic or base requirements. So we have it here in this requirement page. You can see that AI actually produce the core feature. I mean, first the overview of the app and then the core feature, which is the steps that we are going to go through to create the specific modules of code modules, which is first we're going to process the image, and then we're going to do the enhancement, and then the OCR step, and then the vision, the LLM vision extraction, and then storing the output to into the database. Okay, so these are the basic requirements. So we also added dependencies, image output. So all these good for your information, but the most importantly is the steps, because we need this to iterate into the steps to create more detailed planning. So next, what did I do? So let's just skip to step one detail. Yeah. Right. So this then I drill further into step one by asking now create detailed planning step document in step one that I'm inside the base requirement document and use pseudo code on all the operation to be done for this step. So again, AI went and look at the base requirement, look at the step one, right? And then look at this and basically think further, then and drill down into what are the detailed planning for that. So this is the document that they have produced, where say the overview what we are going to do in this step. So first, by setting up the CLI argument parser, and then creating the class and methods that we're going to use in this step. So validating path, checking the supported file and validating the image file and loading into the application, right? So everything else is just the necessary method classes. So this is needed for us then to feed it back into the AI for us to create the code itself. So using this as a context, then I ask, so let's drill further. So into my history here. All right, so when I've reviewed the detailed planning of step one, so my next is basically to ask to fully implement it, to when in coding, basically fully implement, meaning generate the codes that we need for that for the class or for that step. So I said, all right, looks good. And then please implement step one in the class file and then save it to the script folder. So the AI generated the codes for this step in scripts and image input processor.py. So this is basically the code generated by AI for this specific step. So initialization, setting the initial parameters of values, then setting up the argument parser for the CLI input, and then validating the path, validating the image file, and so on and so forth. You can see basically that's what the code has been generated. Right. So so then when I have that, then I ask the AI to integrate it into the main.py. So basically main.py is the one who will stitch all these steps together and then use the classes built in the step process. Right. So it will basically instantiate the class and then set up the argument and then basically process the input so that we can load into the application. That will be the first step. Right. So then I did the same now with the image enhancement, and then also the same for the OCR step processing. So you can see here, this is the step 2, which is the of the pseudocode detail plan, where we will say that we will create the class of image enhancer, initialize it, and process image. Or in the processing image, we are going to convert to grayscale, resize, so on and so forth. So this is the file that has been created. So this is the class for image enhancement processor. So initializing it by setting up the initial parameter values, and then processing the image. But I've simplified it because after some testing, uh, the more complicated detailed step that they have produced actually make it worse. So I asked it to reduce the processing, and then finally I get I mean, for me personally, the kind of perfect output that I want. So just basically just creating converting to a grayscale and then enhancing and making it a bit bigger, and then running basically the brightness and contrast threshold for us to remove whatever in the background, and then just make the text of the document just stand out, and only that's it, right? So that's working for me. And then the third step is basically doing the OCR. So let's just close all this first, and then the step 3 on OCR. Actually, this is the pseudocode where it will create a class OCR processor. In it, initialize it and then also produce this the method for processing image where we'll, we will prepare and then and then try to do the extraction using PyTest. Oh, did I mention this now? Right. So, right. So for this project, I use OpenCV for the image enhancement Python plugin, and I use PyTest for the OCR processing. So PyTest is basically a Python wrapper library that wraps the library that already been created by Google TestRack, if I'm not mistaken. Okay. Right. So going back to the code. Okay, the rest is just the other operation that can support to maximize the output, right? Right. So from this document, I feed it back into to the AI to ask to produce the code itself. So if you notice here, this is the code has been generated from that detailed planning. So this is the OCR processor class where it will initialize and then also validate and then okay. So this is the preparing image where we are going to scale it a bit so it's easier for the test track engine to read the grid, the sections of the image to extract the data out. Right. So I think let's see the result so far that we have. So I have all the processing will be or processing output will be managed in this folder image. So input will be the input folder where this is where the initial raw image will be located. And then after it is enhanced by the enhancement step, it will be produced here in this enhanced folder. Then after the OCR processing, it will produce an MD, a markdown file in this OCR folder, right? So I've run one of the input image just now, the uh, the the 3.jpg, basically this one, right? So this is the first. So let's look at the other side. So let's look at the first one. So this is basically the basic. No, not the basic, but the raw image of one of the receipt. I like to work on receipt because I mean I know to me it is interesting to digitize receipt. All right, so this is the input file. So let's work. Let's see what's the output so far that we can get from this app. Let's clear this up first, and then so to run it, I need to basically run this CLI uh, command. So basically, just saying that to run main.py with the required argument. So first is the input, which is going to use the first JPEG, and then setting up where the output path for the enhance and then the OCR path for the markdown file. Then so let's run this and see the result. Okay, so we have the enhanced image and then the OCR has been processed. So so looking at this is the original. So this is the original. So you can see the original has some sort of shadow and stuff. And then after enhancement, you can see that the text is pretty much uh, stand out from the image. There's no shadow anymore. So it's only you can even our visual eyes can only see text from this image, right? So this is good even for the computer. And after running the OCR, this is the uh, text that have been extracted. Oh, sorry, not that one. This one, the first one, right? So you can see that you can extract the gift tree junction, which is the vendor, and then the item you can see here, drink bottle blue times 2, and then the total, which is 42.60, and the rest of the whatever text in the receipt. Right. So let's work on. I want to continue working on the step 4, which I intentionally left out so that we can see how I uh, you know proceed with my prompting, right? Okay, so what we don't have right now, we have the base requirements, so I need to add that into the context. So base requirements, and then because this step requires LLM vision. So I went out and copy the documentation in OpenAI how to do LLM vision. So this is basically a context to help the AI think because it knows how to do things. Then it's much better for it to it will become much better for it to do the planning. Right. So this one's under docs. OpenAI dash vision dash model. Oh, sorry. No. TXT is .md. All right. Now we have those two in context. Let's ask to create. Oh, so I need a sample of how the detailed plan document. So I'm going to use the step three. Step three. Right. So now we have all the context we need. Now it's time to prompt to create the detailed planning for step four. So first we run it on in architect mode. So okay, now please create the detailed plan for step 4 LLM extraction using pseudocode format. Use step 3 plan OCR processing doc for guideline. This is good when you do the use whatever format as example, so that you can have a a standardized or a similar style every time you produce a new document, right? So blah, 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 I think we can proceed with that. Okay, so it's fine. You can see now the detailed plan for step 4 is being generated. All right. Okay, I see a problem here. Wait, let me just complete this. Well, one of the issue using an architect mode is instead of actually one step process to get the output, you actually have two, because one, it will tell you what it will going to do, and then only that when you agree, it will go and create, or execute the output, getting the file. So twice. So there's not really a problem for me because it only costs like a fraction of cents. Right. So but I can see right now the output format is kind of wrong because this is not uh, the columns that we have set up. So if you notice here in the receipt table that I have created in one of the database I'm using for this project, for this testing project, we only have the vendor name, the transaction date, total amount, and item list. So we need to fix this. So let me try to remember. Uh, okay, I think I know. So in this step process, or on step 5, where we create the database class, we have also specified the table. So I can go ahead and feed this back to the AI to fix the planning. So first we need to add step 4, the document has been generated just now because we want to edit it. Then ask it to fix the output. Check. This is step 5. Let's go back to step 4 because we want it to fix the output format here. See, this is the wrong output format. Right, so we go ahead and ask. Okay, so let's just use architect still. All right, it's good, but we have set up the database table using the schema instead. So just paste it. So please update the output format in the step 4 bit. Right, so it will know what I'm talking about because I have given all the context. So notice now it will revise the format. Okay, so note that now it will follow the structure output that we want. So vendor name, transaction date, total count, and item list. So whatever item list this is. I don't think we'll need this metadata, so I'm just going to remove it. So we just need the items. So I think we can use this. Now, from this document, let me drop everything else first. Drop the step 3, drop the 3, drop the base, drop the base requirement. Okay, so now we have the three things that we need as a context. So we need to create the full implementation file. Right, so okay, please fully implement the detailed plan step 4. Step 4 detailed plan and the in scripts folder. It should be okay. All right, so yep, that's basically it. Okay, I see a few more issues, but we can iterate to fix this. Let it run first. Processing, blah blah blah. Okay, environment, export below. So I think I already have this installed. So main.py. Should we do it now or later? It's fine. Do it now. So it will now integrate this step into the main file. Not yet. It will just going to generate the file first. Okay, updating main.py. Edit the files. Okay, I'm sure this will have an issue because normally if the AI is doing more than one task, it will have an issue basically. I already seen some issue here, so not a problem. Okay, so it will now create the new class file, which is LLM vision processor.py. Yes, and then it will update main.py to use that new step 4. Okay, so let's fix this one by one. No longer need the planning. You know what? For now, it should be okay. Let's just add the new file first. The new file is here, the vision process. LLM vision processor. Right, so the issue I'm seeing here, because now OpenAI key, which is needed for this, is being loaded in directly, but I would prefer this key because the key is in the env file, environment file, and normally I will load the environment file keys and whatever not into the config. Uh, right, so let's do one by one. So let config first, and then we add the new file, LLM vision processor. Right, so when you have that, now, okay, please load the API. Okay, I need the env file, so add.env. Right, so load the OpenAI API key, whatever, in the config file first and use that config in the LLM processor class. All right. Okay, if you look at here, it should now add the OpenAI key in config file. Okay, so that is it. So max up from 1000, which is fine. I'm going to use GPT-4o detail high, which is also fine. Right, so run shell command. No, not here. Okay, so let's double check things. Model API keys there, and then okay, so we'll now load it from the config, which is fine. Model. Oh, I see another problem, so which is fine. Let me just double check this first. Blah, blah, blah. Where's the model? Okay, this is the model, which is fine. All right, so now the problem is in the system prompt. If we look at the system prompt, there is no context provided by or from the output of the OCR. Okay, so let's tell that to the AI. I don't see the additional context input from the OCR text extraction loaded into the system prompt for LLM vision extraction. Am I correct? Just asking basically, we'll answer and we'll do it. Just wanted to think a little bit first. Right, so it says yes, correct. Blah, blah, blah. So let's modify the vision to incorporate the accuracy. Okay. So this base prompt, and now we modify. Now in the process image of the LLM, we will now also include the OCR result. Okay. Update main py, blah blah blah. So edit file, yes. And I would need one more thing. Just want to see what kind of output from the LLM. So I need to prompt that as well. All right, so that would be the new system prompt. OCR text is here, so now OCR text is included here. Prefer the more confident reading. Okay, good. Now I will add the base prompt and the OCR context. Okay, I can see that now. Okay, so I'll just need it to. Okay, and you please output the LLM result from the result first in the console so that I can see that the LLM inferencing is happening for better tracing. Okay, so no. All right. Okay, so what do we need now? So I think it's ready for testing. So let's close all this first and then look at main.py. We need so getting or process the image using vision class, and then we'll dump the result. And from this result, you can see what's the nina. JSON file. Where will it save it? LLM output path. Where's LLM output path? Oh, this is the definition. OCR path. Join OCR path LLM.json. Oh, okay. You will input it back into the OCR. Okay. You know what? I don't want to to make the video too long. Let's just go with this and run it. So clear this first, and let's just do the one again, right? So let's run it. Oh, let's see. Right, so loaded, enhanced, OCR done, and then we see the JSON here. Oh, all right, so we got vendor name not there, empty, and then we have the, how come it's still processing metadata and no items? This is not correct. Oh, we got an error here. It's an image expecting value. Okay, let's just see if I can understand why there's an issue here. Right, let's remove the not important things first, and we the docs. No, let the doc be stay there. The requirement docs need config. Okay, right. I got this error in the execution of step 4, and then paste error. Can you figure out? Nope. Invalid JSON. In this case, I see the response from the player isn't returning valid JSON. It can be passed. JSON load, whatever. Not exactly how I want it to be, but you know what? For now, it's not this detail that I want to worry too much about. No, I will run it myself. So let's just try it again. Okay, okay. All right. Now we got the vendor name, transaction date, amount, which is correct, 4260. And also we got items and metadata. I really don't need this metadata. So let me just remove that first. Okay, that will be coming from there. And then the vision processor. Let's check where the metadata is. Add metadata, processing time, extraction data. Let me double check so that I don't cause an error if I comment this out. Then it depends on the processing time, so it's still here. The score should be calculated, which will give you information. Okay, this can be removed. Save it, and then try again. Right. Okay. Okay. Enhance OCR, and then feed it into the. There's still metadata there. I really don't want this. Let's see if there's more. Oh, okay. So it says here it needs metadata. So I don't say. Let's just tell it I don't need this. Okay. If you can read certain information clearly, indicates that's the thing metadata. So nope, don't need that either. So where else metadata? Right. So exception again. I don't need this. I just put it here and comment it out. So that, it just in case I want to put it back, it's there. Okay, okay, okay. I think that should be it. Save and final test. Okay. All right. So no more metadata. So I only have items here, which is good. Right. So the next item to do is to bring this into the database. Now let's just drop everything. Now we need to add the main PY. We need to add the LLM step 4. Oh no, not this one. This one. We need now test DB. We need the output from the so images OCR one underscore LLM .json, which is the output. Yes, yes, yes. What? Oh, let's just copy this. Here. The heck. All right, so let's add that thing one. All right, so okay, now we can prompt. So architect mode. Now step 4 is successful the integrated in main process. This stitch is continue the main process to store the output of LLM processing into the database. Use the test DB file for reference and also one underscore LLM.json as the example result from the LLM vision processing. It should be it, right? Script config to the chat. Okay. Why though? Mm, edit the files. So main.py will add database processor. And then we will save the result from the LLM processing. Okay. You know what? Let's just try them. Okay, let's just remove everything else. Just this. Okay, so note that we only have one record from the test DB test insertion. Let's now see if we can get the text extract from this one.jpg, which is from the input file, into the DB. Let's go. Okay, enhance OCR vision. Oh, cool. So this structured data is now successfully stored in the database. Let's double check. Fresh. There you go. Good. Okay, next one. Let's do the third one. Okay, we have number one, number two. What's the number? Number two. Okay, so number two. So just for your information, the cost for running this kind of app will be the LLM vision cost, because every time you run a prompt to extract data, hold on, to extract data from an image, it has a cost attached to it, right? So, and then I will show you how much it will cost. Right, so this is the second. Total amount is 46.41. So let's look at that. So this is the other receipt. 46.41 is the total. Good. And this there's a 5 item there. And then let's look at the enhanced version, which is good. We can clearly see the text because it's now is being highlighted. And then the second JSON, we have all the 5 items in the item list. Okay, vendor name is unknown because we can't actually see the vendor name. Actually, if this is clever enough, you can actually see that the vendor is Clover, maybe. But anyway, it's not really that important. Okay, so that's good. Close it and then see if this is actually updated in the database. Okay, yeah, vendor names unknown just now. Total 41, and these are the items. Cool, cool, cool. Okay, right. So don't know if you want to test another one to get another just another receipt. So just Google image it. So just do a receipt and do an image. See if we can find another good we can use. This is too long, so don't want to use that. This looks like something we can use. Yeah, let's use this. Can we save this image? Save as. Yeah. Okay. Right. So let's name it number 5. Just to be clear. Okay. So going back here, do we have number 5? So yeah, number 5. So this is the receipt just now. Let's try and run it. So input is input number 5. Let's go. Right. So enhanced OCR, come on. Okay, OCR. Then LLM vision. Cool. So we got the result 5450 is the total. Begotel. So Begotel 5450. So total is correct. And then there is 1, 2, 3, 4 items. Is that correct? 1, 2, 3, 4 items. Yeah. Let's see if we got it in the database. Yep, the bag hotel gross whatever it is, the 450 and the items. Okay, so I think that should be enough to convince myself that this is at least at this point is um, reliable enough uh, operation pipeline to convert from uh, paper document into data that we can save in the database. So I hope you get the idea and some sort of lesson from this video. And okay, so I did mention the cost, right? So I prepared this. So we use GPT-4o Vision just now. So for that kind of image or any particular image, let's just say lah that it's 1,000 width and 1,000 kind of image. The cost for it's still less than 0.01 cent per image. So if you will yourself have to do the data entry, converting this paper document, typing in into the computer, I think anything that 0.001 or 0.002 as a cost of not doing that and have the computer or any application doing it for you instead. I think that's still rather cheap, right? All right. So with that, I think that's all for now. And if I have another use case I want to share, I'll be back. Right. Thank you guys. See you guys later.